Good morning, class. I'm Mr. Masharia. Welcome back to our class. Yeah, during our last class, one of the students sent a area that you want to look about. That is the approximation and ALAS. So if you have any topic that you have a problem, just keep sending those topics that will be tackling them. Today, let us just tackle this topic. Yeah. If you are there back at home, just be prepared. Just take a book, have a calculator with you, have a pen. Yeah, and let us look about this topic, how to go about it. So welcome. Yeah. So about the approximation and ALAS, there's something that we need to know here before we go to the prerequisites of this topic. That is the significant figures. Significant figures. This is one of the areas that we need to know in this topic. We know significant figures start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. No. Up to 9. All these numbers are significant figures. But for this one, they are automatic significant. But for this one, we have in some of the cases where it is significant and some cases it is not. So 0, for the trapped 0 is always significant. What do I mean by the trapped 0? If I look at any number here, these two, they are in between the two numbers. So those are trapped 0. So they are significant. Okay. Then we have the reading zeros. The type of zero that we have, reading zeros. These zeros, they are never significant. What do I mean? When you look at any number, maybe 0.00001, all these zeros, they are not significant. Any zero come before any number, it is not significant. You need to understand that. So we go to another type of zero, that is trailing zero. Trailing zero, in this case, we have two. With decimal point, it is significant. Without decimal point, it is not significant. What do I mean here? If I look here 500, without any decimal point, these two will not be significant. But if I look 500.0, all these three are significant. So we need to understand in those situations where 0 is a significant and those situations where 0 it is not a significant. So you need to understand these three type of 0 that you have. Trap 0. Zeros in between the numbers, they are significant. 0 which are leading before any other number, they are not significant at all. And trailing 0, we have two conditions there. If they have a decimal point, automatically they are significant. If they don't have a decimal point, they are not significant. Let us do example. But automatically all other numbers, they are significant. But 0 have conditions. You have to understand this. This is one of the subtopic of this topic that you need to understand. At the end of the topic, you have to know what are significant figures. So let me come here today. Maybe we go about this example. Yeah. Let us go through those examples. The first one, we have the reading zeros before the numbers. That means we come back to our concept here that you need to understand. Those zeros, they are reading zeros. They are before any other number. That means automatically they will never be significant in our case. These 4 zeros, they will never be significant. So we have only one significant figures here. Only one significant figures. Come to our second example there. That is 0.201. We have this 0 reading zeros before any other number. But I've said the number where you have a decimal point, but the reading zero will never be as significant. So this one is a significant. So we have three significant figures here. Come to our third example there. We have 400 there. Those are trading zeros, but we don't have a decimal point. These two, they are not significant. So you have only one significant figure there. Come to this 4 million, there were our fourth example there. So you just have 4 million in my pocket without decimal point here. This 1, 2, 3, 4, 6 zeros, those are trading zeros. They will not be significant. But when I load, I have 4 million.00, now this becomes significant there. So that's why we wrote our Kenyan money, we have 100 bob. We have to consider the point of the decimal to make them significant. To make them significant. So for 0, we have to consider the type of 0 that we have. The trapped 0, the reading 0, and the trading 0. We have to consider this concept. You must understand today. Given in an exam to maybe your last answer was 500. Just an example. And the last point there, you are told to write your answer maybe to 4 significant figures or to 3 significant figures. You are told to write your answer in 3 significant figures. Maybe your last answer was 500 and I told you to write your answer to 3 significant figures. How do you go about it in exam? You just come to and put 500, then you want point there to make them significant. Because we have said for trading zeros, without a decimal point, they will never be significant. They will never be significant. So for this one, 500, without decimal, we have only 1 significant figures. But when we add a decimal point there, now we have 3 significant figures. So if your last answer in exam is 500, maybe 100, I want to write your answer in 3 significant figures. Just add a point there to make them significant. So this concept you must understand, that have type of zeros. That 0 becomes significant in different cases, not always. You have to understand. So let me hope you have got the concept of today. That concept is with you. That the type of 0 that have is trapped. That is the 0 in between the numbers. They are always significant. The second concept that you need to get the other type of 0 you have the reading zeros. Zeros before any number, they are not significant. And the trading 0. So let us do the final example and go to the second concept. So any inquiry that you have, may keep studying those comments, the number. You can just text or send an SMS in WhatsApp. Yeah, and set those comments. So let us do the final concept here. So lights 2, 3 significant figures. So maybe the first one maybe is 0.201. This is the final example I want to do, because I want to understand this concept very well. So let us do those examples. Yeah, those examples. Maybe here 4.1, like that. So the first one, I want to write in three significant figures. The first example, you have said leading zeros, they are not significant. So our answer here will be the same. It will be the same. For the second one, to write in three significant figures, it will be, just check the fourth one, just less than 5. So just loud off, so it will be 0.00100. These two, they are not significant. So 1, 0, and the other 0, they are significant. So that's how to go about it, three significant figures. About this one, three significant figures, we have 0.2.000041. Write in very significant figures there. So it will be, so all these are trapped 0, they are in between the number. That means the trapped 0, they are always significant. So very simple. So just go. So three significant figures. So it will be 2, 0, 0, like that. Because the fourth one is less than 5. So let me hope that concept is with you about the type of the 0 that we have, and when it is significant and when it is not significant. So we got to the second concept about this topic that you need to understand. That is about how the type of error that you have. The first one, you have absolute errors. Absolute errors. So absolute is denoted by Y. It is Y, or any other letter can be. So just want to denote them. So plus or minus change of Y. So if it was in a gradient and I want to get the absolute error, so this is absolute error. So means the actual number, and maybe how when you add it or you minus. So absolute error is error of uncertainty when measuring any geometrical and non-geometrical things. So absolute error, so if we put in our case Y, which can be any other letter, don't necessarily be Y. So can be change of Y, either plus or minus. So what do I mean? If the actual number is here, that is Y. So, and maybe the wrist measuring unit of this one, maybe, so this stage of Y can be the positive and B can be negative, because this will be minimum and this will be maximum. But we'll come to this one. But the absolute error is error of uncertainty, which is always denoted by this one. We'll come to this. Yeah, you can go with me in using the KUTV mathematics form 3. That is the fourth topic. Yeah, you have a KLB, you can open that. It is, but then how you can denote the Y. So we have the second error, which is called relative. It is the relative error. So now this one is absolute divided by the actual. So that is absolute error. So the first concept is to know what is absolute error. That is error of uncertainty. To know the definition of this error. So the other one is the relative error. And then we go to the last concept, which is the percentage. Percentage error, which is now absolute you divide by actual, which is the relative, you multiply by 100. You can simply denote by that is relative Yeah, which can be percentage error. We can denote it like that is absolute. You divide it by actual measurements, then you multiply by 100. Or simply say that is relative multiplied by 100, and you get percentage. So these are the three concepts that we'll check today, how we go about them. Yeah, let's go to the first concept here. So which is absolute error? So allow me to remove this one. If today I decided now maybe to measure the measurement of this, that's yeah, and maybe I'll get maybe 3 centimeters. I'll use a rule to measure there. I'll use a ruler to measure this one. But automatically there will be an error of when measuring of uncertainty. A good example, when you go to laboratory to do practicals, you are to measure using a measuring cylinder, get the maybe solution X. You are to measure maybe 20 ml. Millimeters of that solution, and you add to maybe to a solution W. So automatically, when measuring that one, that an error that I was taught by my teacher, that is Mr. Gashwe, about the meniscus error when measuring, automatically will get a different. Automatically will get the different measurement. That is why for the practicals, when it comes to, we don't have the actual answers. The answers are always, an error when maybe plus or minus. For any actual, we don't have actual answers when it comes to practicals, because error of uncertainties, which is absolute error, must be always committed. So that's why no one will ever get the. That's why during the final exam, that is KCSE, we'll have the school value. We don't have the actual for the whole country. We don't have the actual answer, because for the different factors. So error of uncertainty must be there during our practicals when measuring things. So if I say today, maybe the measurement of this one is 3 centimeters. Want to get the relative error for this one. The absolute error, that is the first one. So you come and check the wrist measuring unit of the measurement given. If we say this is 3 centimeters and the measurement given is 3 centimeters, we don't have a decimal point there. So the wrist measuring unit for this duster is 1 centimeters. And because the error can be in either side, they have the upper bound and the lower bound, so we divide by 2. To get this is 0 point, you have the calculator, 0.05 there. So when you come here, maybe if this is the actual 3 centimeters, the upper bound and the lower bound for this one. So you just take 0.5, you add. So if this is 3, this will be 3.5. And this will be minus 0.25, it will be 2.5. So the absolute error can be plus or minus the change of. That way they can be noted by, but can be any letter, can be denoted by the plus or minus the change of that unit. So this one can be 3 plus or minus 0.5. So 0.5 can be in any side, because we said this is the actual measurement. This is the actual measurement. But we can have committed error for this one, can be 3.5 and it can be either be 2.5. Hope you are together there. You need to get the wrist measuring unit. Then you divide by 2, because it can be in any other side, can be the upper bound or the lower bound. So 1 is all about this, the whole of it. 1. We need to divide by 2 because we have the 2 portion here, upper bound and the lower bound. And the maximum upper bound is 0.5, considering our limit there. Hope you are together up to there. And any question, keep setting them. So let us now go to another example. If given this is an A4 paper that which is a rectangular, so if this is maybe 10 centimeters and this is maybe 7.1 centimeters, I want to get the absolute error. I want to get the relative error. I want to get the percentage for those 3. Allow me to remove this one. For the absolute, maybe I want to find the area. So find the area of rectangle. Yeah, like that. So, and get the absolute, relative, and the percentage. So the actual, it will be very simple here. First, you look the first step to follow. Check we know the area. We know the area. For the first step, it's going to know the area is length times width. Actual area, it will be 10 times 7.5, which will be 75 centimeters squared. We come now to, we check want to get the maximum. For this one, you must get the maximum, the upper bound part of it, maximum area. So I've said, you just come and check the measuring unit of given. For this one, there is measuring unit. We don't have a decimal point, so it is 1. It is 1. This is 1. For 10, it is 1. So you just come here. Before you get the actual, the measuring unit. To be very simple, so it is, for this one is 10. So it will be 10. So this one will be 1 centimeters. And because we have the upper bound and the lower bound, we divide by 2. You get 0.5. So for this measurement, that is the length. When you come to the upper and the lower bound, if this is the actual, which is 10 centimeters, 0.5, you add 0.5. The upper bound will be 10.5. And the lower bound for this one, it will be minus 0.5, it will be 9.5 centimeters. So for this measurement of this length, the upper bound, the wrist measuring unit, it is 1 centimeters. Because we don't have any decimal point, so it is actually be automatically become 1. You divide by 2 because we have the upper bound and the lower bound. Upper bound and the lower bound. So the upper bound, it is 10. You add, because the upper bound, upper limit of this measurement can be go up to 0.5. The lower limit of this measurement can go down up to 9.5. We go to the other part, the other measurement, which is width. It is 7.5. There is measuring unit here. You just come here and put 0.1. The right-handed side figure, the last left-handed side, the right-handed figure on that far end become the become the wrist measuring unit. You just replace this, you just come, if it was like 0.75551, you just come and put 0.01. The last figure become 1 in that decimal point, in any other given decimal point. So in our case, we have 7.5. So the last figure, after the point, you just put 1. Are we together here? So if it was like 20.001, so it will be the rest. So we'll come to this one. So let's check about the, we put the last figure to be 1 there. So our wrist measuring unit here, it is 0.1. So you take 0.1, you divide by 2 to get the upper and the lower bound. So take your calculator there. 0.01. You divide by 2. Automatically it will be 0.05. So you come here, the upper bound, it will be the actual number 7.5. The upper bound, it will be, you add this one to this one to be 7.55. The lower bound for this one, it will be, you minus this one, you minus 0.05 from 7.5. So it will be very, take your calculator to avoid committing an extra error when calculating the errors. So just avoid, just use the calculators to calculate, to find it. So it will be 7.45. The lower bound for this one, it will be, so this is the actual number, the upper bound, and the lower limit, or the lower bound of that number. So now you can able to find the area. So we have already have the actual area. Now you come and find the maximum area. Maximum area is given by the upper bound measurement. So upper bound for this one is this one, and upper bound for the our other measurement is 10.5. So to be very simple, because the area is width times length, so it will be 10.5 multiplied by 7.55. So just take your calculator to avoid committing an extra error when calculating the error. So 10.5 multiplied by 7.55, you get 7.9, which is 2 points like that centimeter squared. That is our maximum area. So we get our minimum area. Our minimum area. We go to the, now our minimum area is given by the lower bound of our measurement. So lower bound of, we have them. So that is 9.5 multiplied by 7.45. You take our calculator there, you multiply. So it will be 9.5 multiplied by, so you get 70.775 centimeters squared. So absolute area is given by, so we continue from there. Absolute area. So we want to get the maximum minus the minimum. So maximum in 7 point minus the minimum, which is 70. You minus, which is 79.25. You have your calculator, you are doing this with me. You minus 70.745. You get 8.5. 8.45 So allow me to remove this one because I've black. So you can check that if I get the same answer there. Yeah, for this one have to divide by 2 to get the absolute. So divide by 2. So sorry, I've forgotten that one. Divide by 2 to get the absolute error, which is absolute error is equals to 4.25. 4.25. Yeah. So we want to go to our relative. That is our first quality. We go to relative error. We said relative error, very simple, is absolute. That change of y plus or minus divided by, which is absolute. So let me not complicate this. So just absolute divided by actual to be simpler. So you just take that one. Yeah. You take that one. You divide it by the actual. The actual was, it was 75. To be very simple. So that is 7.25 divided by 75. You get 0.0566. You just write for in 4 significant figures. We'll add off that one to be 7. So that is our absolute. That is our relative error. Now we go to the last one, which is the percentage error. So that is very simple. Percentage error is equals to relative error multiplied by 100, which will be 0.05667 multiplied by 100, which will get, you get, just multiply, so it will be 5.667%. So that's how to apply and how to get the absolute error in application part of it when it comes to multiplication. So the concept here you need to understand is how to get the absolute. You have to look for the maximum, you have to look for the minimum, and to know the absolute when it comes to application to the multiplication. Now absolute, it is the maximum minus the minimum divided by 2. You get the absolute error. And to know that the relative error when it comes to multiplication now, that is but what changes is absolute here, but the others remain the other, how the formula it goes. The concept, what changes about the absolute, because the actual formula of the absolute when it comes to the addition and multiplication, let me remove this one. Absolute, how the absolute changes due to the different computation of maths. When it comes to plus or minus, so it is either change of y plus or minus. That is very simple. But when it comes to multiplication, we are talking about the absolute. When it comes to the multiplication now, it becomes the maximum minus minimum divided by 2. When it comes to division, we want to go there. We have another concept. But before you go there, let us do another example on multiplication. For this one is very simple. Yeah, but we'll come to it. But that one is very simple for the plus or minus. The mostly what come in paper 2, section 1 in maths, application may be either multiplication and division. So in 2015, that is KCC, you have that question. When you have your mid familiar, you can open. You have that question that was always there. How to get, that is area that is always there. How to get an area, find the relative error, 2015. So given that the measurement of the, that is be 60, and this one was, maybe it was 7.6 there. We are trying to find the 2015 there. Let me draw something which is good. Yeah, we are trying to find the relative value of that one. So you can open the mid-family and get the samples of the question that have come to the or last KCSE. You either to get the relative or to get the absolute. So we're trying to get the this is 60 centimeters. So allow me to put the, so sorry, the unit must be there. This is 7.5. Yeah, it was there in 2015. Yeah, but they are always there. So there are very many. You can do a lot of example back at home after getting the concept. So how to get the relative error? So for this one, first you must get the absolute. You must get the absolute for us to get the relative. Because we know the relative is absolute of actual measurement. I said the first steps to follow. The first step is to get to know the formula of finding this one. So the formula is area is equals to length times width. I want to do this one, be one of the equations that was there in 2015. These are always be there in paper 1, paper 2, section 1. How to get the relative error of a given area over different geometrical figures. So it will be 60 multiplied by 7.5. For this one you get, just use your calculator. It will be very simple. 60 multiplied by 7.6. You get this one to be actual area ni centimeter squared. So the second, that's the first step we said. I need you to understand these steps to make sure you always follow them, because you cannot know where to go unless you know steps to follow to get there. So after that, you want to get the maximum. You come to the wrist measuring unit. Of the measurement given. So we have 60 centimeters. The wrist, we don't have a point, so it will be 1. 1 divided by 2, 0.5. The other one have 7.6. We say this one be 0. The far edge number, it will be 1. So 0.1. So that's very simple. You take 7.5, 7.6. The last digit in your light-headed side only automatically become 1, 0.1. So 0.1. So this is 0.1 divided by 2. You want to be 0.05. Very simple. So from there, have you get the wrist measuring unit now? You can able to get the upper bound and the lower bound of those measurements. So for this one, 60, if this is actual, this one automatically will be 60.5. That is the upper bound. The lower bound for this one, it will be minus 0.5. It will be 59.5. So for the other measuring, that is the width of 7.6. So the actual is 7.6. The upper limit you can go, it is 7.65. The lower limit you can go to that, it will be 7 point, you minus. I don't want to commit, so 7.6, you minus 0.5 or 0.05. You get 7.45. So after that, now you can be able to get our maximum area. So allow me to remove this one. So our maximum area will be equal to, we said the maximum area is given by the upper bound. The upper bound for the two measuring, they are the two. So it would be 60. These two, they are the upper bound. So they give the maximum, give our maximum area. So which will be 60.5 multiplied by 7.65. So the minimum area it will be the row limit for those measuring unit there, which are 59.5 multiplied by this one is 7%, sorry. So I've said you can commit an error when calculating error, so you must be very keen when doing that. So I've just check. So for this one, so sorry, this one is 5. Yeah. So avoid committing more errors when calculating error. So just be very actual. Yeah, allow me to need this one. This one is 59.5 multiplied by 7.55. You get 49. Yeah. This was too wrong. 49.23. Yeah. Absolute error is given by maximum. I have said in multiplication minus minimum divided by 2. So maximum area is 62.83 divided you minus 449.23. You divided by 2. So take your calculator, do the same. 462.83 minus 449.23 divided by 2. You get 13.6 divided by 2. You get 6.8. That is our absolute error, which is too high. So allow me to remove this one. So for us to get our question was to get the relative error that was there in 2015. Relative error is equals to absolute error divided by actual. So this one, so absolute error is 6.5 divided by the actual area. Actual area was 456. So very simple, divided by 456, you get 0.01491. Just write in 4 significant figures because that is the standard requirement. Yeah. And we said for this one is not significant, so 1, 2, 3, 4. Those are 4 significant figures. That is our absolute error. That was the question. That is what you have been told to find. So that's how to apply in multiplication. Let us go now to division. For division, I'll use just a very simple. Let us first go to plus and minus. So hope you have understood. Let's go to the other. That is a multiplication. Maybe that one you are good now. You can able to apply. Just go to the made from area. So those back at home and you maybe have a problem on that, just keep texting and maybe set those comments, the area that you want us to tackle the next time, and maybe and you set the answers that you are getting with me back at home. So we go to the now plus or minus. So for this one, it will be very simple now. If you're given a number there, the measurement of anything like what we did, 4.9. The absolute for this one, maybe centimeters. We're trying to get the, for this one we did, so when I was explaining about the example of the duster. So, but let us do another example on the same. When it comes to plus or minus, multiplication, that's how to go about it. Plus or minus, so this one, it will be absolute error is 4.9, and we said, oh no, plus y plus or minus change of y. So our 9 here, so simple calculation there. So the risk measuring unit, we say that one to be 1. So the risk measuring unit (0.1) we divide by 2, got to be 0.05. So the upper bound and the lower bound for this measurement 9.4. So if this is actual, the upper bound here it will be 9.45, and the lower bound for this one, you just minus 0.05, which will be very simple. Take your calculator, 9.4, you minus 0.05, you get 9.35. So for those two computations, that is plus or minus, they are very simple to go about. That is the way to go about it. So they are not complicated, because our absolute in this case now remain to our quotation, remain to how we denote it, plus or minus change of y. So, but when it comes to now to division, which will be our last part of today, how to apply given, maybe a very simple sum. So simplify. No. Find the relative. Yeah, so given. So find the relative value for that sum. So amount all, so which is automatically like that. So all divided by 200. So for this one now, the formula for the absolute now changes. For the division, absolute LS given by the maximum. So let us come to that one. Let's just first before to come to that one. So the figure given there, if this is 40, so the risk measuring unit for that one, we check the first one, the steps to follow before we come to that one. This one, it is 0.1 automatically, so divide by 2 to be 0.05. For the other one, so this one, the maximum and minimum, if this is 40.5, 40.1, the maximum and the minimum remit, this one will be 40.15, this one will be, you minus 0.5 here, it will be 40.1 minus 0.05, you get 40.05. So for the other one, allow me to remove this one. For the other one, 200. The risk measuring unit, because we have a decimal point, is 1. We don't have the decimal point, so the risk measuring unit So we consider if you are not given the decimal point, the risk measuring unit become 1. But if decimal point is there, we say the last the last figure in our light-headed side become 1. So this is 1 divided by 2 to be 0.5. So the maximum and the minimum limit of this number 200. This one it will be maximum number, or the upper bound it will be 200.5, and this one will be 200. No. You minus 0.5, 200 minus 0.5. It will be 199.5. Yeah, like that. So I don't want to commit an extra error. So let's get the absolute now, absolute error. For this one, automatically become the maximum divided by minimum. Maximum divided by the minimum. We'll get the absolute error. We are moving together. Let me confirm that one. No. So sorry. We have to find the So we want to find the absolute error. The absolute error is maximum. I've said just division because our sum is very simple. Maximum divided by minimum. So our maximum number here for this one was 40.1 divided by, just confirming there. So divided by the minimum. The minimum number for this one, it is 189.5. So this one will get 40.1 divided by, so you get 0.2 4 second figures, it will be 0.2013. So for us to get the relative error in that one, so we get the actual sum of for our question was, allow me not to remove it, allow me to do it here. The actual sum for us was, so the actual computation of our sum is 40.1 divided by 200, which will get 40.1 divided by 200 will get 0.2005. For you to get the relative is the absolute divided by actual. So like what we said, so it will be 0.20 divided by 20.05, which will be 0.013 divided by, and you get the answer there will be 0.0001. So the concept about this topic, that is approximation and errors, you need to understand, like we said, the first step was how to write the significant figures. The type of zero that we have, that is trap in zero, lead in zero, and trail in zero, where zero becomes a significant and why it is not a significant number. The other thing is about when to find the relative error in a different computation. So we have said when it comes to plus or minus, very simple, the formula of the absolute error remain. When it comes to the multiplication, the formula for the absolute error, now take the maximum, so divided by 2 like that. So Get the concept, do a lot of example, go to the visit the made familiar, those the last exam that have come. So thank you for the staying together during this class. So you can set the comment that the other topic that you want us to tackle. Hope you have understood those concepts. So we'll only tackle the topic that you want us to tackle. So set those comments, keep them coming, and we'll tackle the other topic. So the Anne from Muranga who said about this topic, hope you have understood the concept. So let us meet next week. Let us meet next week for those topics that you want us to tackle. Thank you for your time, and may God bless you. Thank you.
Dreams.